Hey guys, so today what we are going to do is we are going to try to understand Lewis structures. So we are going to take the example of carbon dioxide molecule, but first we should outline the step. So step number one is find the most reasonable structure. The most reasonable structure is generally symmetrical and has the least electronegative element in the center. Now if you see carbon and oxygen, these are the two elements there. Now we know that least, right, least is carbon is least electronegative. Generally the rule of thumb is towards the right of the periodic table you have more electronegative atoms, right, and towards the left you have the most positive atoms. So let's place carbon in the center, it is least electronegative, and let's place oxygen in the periphery. So it looks symmetrical, right? Now step number two is calculate the number of shared pair of electrons, that is S. Now how do you calculate? The way to calculate is you have to first find out what is N, and what is N actually. So it is the total number of needed, right? Total number of needed electrons in the valence shell, needed in the valence shell, right? And what is A? A stands for total number of electrons that is available. Okay, so let's find that out for this CO2. So we will start by calculating the N. Now how do we calculate the N? Now there are three atoms, each of these are going to follow the octet. Now what does octet rule says? The outermost valence shell should have 8 electrons because it resembles the noble gas configuration, right? That is why. So we have 2 times 8. Why 2 times 8? Because there are 2 atoms of oxygen and each one requires 8. So that stands for oxygen. And then let's calculate 1 times 8 for carbon, right? So 2 times 8, that makes out to 16, plus 8, that makes out to be 24. Now we need to calculate A. And what is A? The available number of electrons. Now if you remember, the oxygen, the atomic number of oxygen is 8, and that of carbon is 6, right? So 6 goes to 2 4, the valence shell electron is 4. 8 goes to 2 6, and the valence shell electron number is 6. So this is what you have in hand. So let's write that out. So again we'll first write for oxygen, right? So 2 times 6, right, plus how many we have for carbon? 1 times 4, so that is 12, plus 4, that comes out to be 16. Now we need to calculate S. Now if you remember, our motive was to calculate S, that is the number of shared pair of electrons that is needed. So S is equal to, in this case, would be 24 minus 16, that is equal to 8. So 8 pairs of electrons are going to be shared. So let's start by forming bonds, right? So we know carbon has 4, so let's place them right here, right? Oxygen is 6, so let's place 2 of them for each oxygen atoms right there, and the remaining are to be placed as lone pairs. So how do you actually write them? So the way of writing them is you write them very close to each other. So C and these two, I have written them very close to each other. That suggests that they are together in a bond. So this is Lewis dot structure. Another way to write the same thing is by representing these bonded electrons as dashes. So you can write C double bond O, and you can mention let the lone pair electrons just like that, right? So this is how you draw the Lewis structure by using the shared number of electrons, that was 8, and the remaining was just placed as the lone pair electrons. Now the key thing is here the atom, the molecule of carbon dioxide was neutral, right? So you did not have to accommodate for any charges. But let us see what will happen if there is a charge. So a similar example is ammonium ion. So again, the structure is same, most reasonable. Remember, so nitrogen is, so ammonium ion is NH4 plus, right? So nitrogen is more positive here, right? It's more electronegative here, right? So let's place nitrogen here and the 4H here. Now we are going to write the same formula for this. So N, again, how many electrons are needed, right? Now hydrogen, if you remember, hydrogen does not follow the octet rule. It instead follows the duplet rule. It needs only 2 electrons in its valence shell. So we have 4 hydrogen times 2, that is for hydrogen. Then we have 1 nitrogen. Nitrogen needs 8, right? So 4 times 2, 8 plus 8, that becomes 16. Now let's see how many are available. Each hydrogen has just 1. So 1 times 4, right? And nitrogen, if you remember, nitrogen was 7, right? The atomic number is 7. That means 2 comma 5. 5 is the outermost shell. So we have 5. Now that comes out to be 9. Now there is a peculiar change that you must do. And what is that peculiar change? Now you have to adjust the charge. Now in case of ammonium ion, there's one positive charge. That means positive means you have already lost 1 electron. That means minus, right? That means you need to subtract 1. That means now 8 electrons are going to be available only. So followed by this, we use the same formula. S is equals to 16 minus 8. That equals 8. So let's start forming bonds. Now, so each hydrogen would have 1, 1, 1, right? Now this would be used by, now remember, the nitrogen has 5 in its outermost shell. So these are going to be the shared electrons, right? So these are going to be the shared electrons. Now this lone pair of electron that nitrogen had, this lone pair of electron would be donated, right? Would be donated to the H here. So they together form a coordinate bond, right? They together form a coordinate bond because the entire lone pair is donated by just nitrogen atom and not the hydrogen one, right? And then you add NH plus here, right? Then you simply add an NH plus, and that's how it's done. So I hope you're clear with the steps outlined here. I hope this helps.
Thanks for watching this video. We love helping you learn. Please be sure to subscribe and watch some of our other videos.